Okay, in objective 7.3, we're going to talk about special right triangles. So remember in objective 1, we talked about right triangle trig. This is kind of an extension of that. There are two specific types of triangles that we call special because they will always follow the same pattern in terms of what their side lengths are compared to what their angle measurements are. So the first one that we're going to look at is called a 45-45-90 triangle. And what I want you to do, I want you to change these x's into ones. I think it's a little bit easier for us to understand if we do it that way, whereas, and I just want you to change this one into root 2. So I think it's a little bit easier for us to understand because there's not as many variables going on here. So I want you to change that one. So what you need to recognize with this one is that we've got an isosceles triangle because two sides are congruent and two angles are congruent. The two legs are going to be the same. They're always going to be 1, and then the hypotenuse is going to be root 2. Now, if the triangle gets bigger, but the angles are going to stay the same, okay, the sides are going to be in the same proportion as the 1, 1, root 2, or the original 45, 45, 90 triangle. So we're going to set up similar triangles like we did in 7.2. The second type of triangle is called a 30, 60, 90 triangle. Again, I want you to change these x's and every side. I want you to change the x here to a 1, the 2x to a 2, and the x root 3 just to root 3. Again, it just keeps it cleaner with less variables. So here is probably the more difficult one to remember where the sides go. This is how I remember it. Here's the 30. Across the triangle from the 30, that's going to be the shortest side, so that's going to be 1. And then you can think about the other side as being the root 3, so the other leg to be the root 3, and the hypotenuse is always 2. So if you can remember, basically, if you can remember two of the sides where they go, you can always find the third side using the Pythagorean theorem, but it's easier just to remember all three sides. So I always start with the angle across from the 30 degrees. That's 1, and then I go to the hypotenuse 2, and the last side is root 3. That's how I remember it. It's just something that you're going to have to get into your memory, but you will as long as you practice all these problems. Okay, now example number 1, find the exact side lengths of each triangle below. So this is how we're going to find out these exact answers. We're not going to use trig because that sometimes doesn't give us exact answers. We're going to use these triangles. So in example A, I've got a 45, a 90 degree angle, and that makes the last angle 45 degrees to make it 180. And I want to find these last two sides, so x and y. So I'm going to go ahead and draw a 45, 45, 90 triangle just like there was above, but I'm going to draw it in the same direction that this triangle is going. So I'm going to label the sides or the legs of the triangle 1, 1, and then it makes the hypotenuse root 2. So now this turns into a problem like we had last week where you've got similar triangles and you're trying to find a missing side. So if I go ahead and try and find x first, and I know the side length is 6, that's the same lengths as the other two legs on the other triangle. So I'm going to set up a proportion using x over 1 equals 6 over 1 and cross multiply here. So this one's simple. X is just going to equal 6. And then for the y, I'm just going to do the same thing. I have y, I'm going to use 6 again, and then that means I have root 2 and 1. So I have y over root 2 equals 6 over 1. So I'm going to go ahead and cross multiply here. 1 times y is just y, and then 6 times root 2, remember, is just 6 root 2. So there's that missing side. Okay, so just setting up triangles. The big thing is drawing the first triangle correctly. So letter B, I see that I have two sides congruent, so I know that this is also going to be 3.5. So if two sides are congruent, that means their two angles are also going to be congruent. So this is a 45, 45, 90 triangle. So again, I'm going to go ahead and draw this. Okay, good idea just to practice this. Even if you think you can do this in your head right now, I just urge you to practice this right now. So again, I'm trying to find this hypotenuse here, so I'm going to go ahead and set up a ratio. 3.5 and y, 1 and root 2. So 3.5 over 1 equals y over root 2. So I'm going to have 3.5 root 2 equal to y. And that's it. Okay, let's take a look at some 30, 60, 90 triangles and C and D. So I'm going to go ahead and redraw for C in the direction that this is going. Okay, this is the 30-degree angle up top, just like it is in the picture. And then this is going to be the 60-degree angle to make it a triangle. So again, across from the 30-degree angle is going to be the 1. The hypotenuse is going to be 2. And then the third side is going to be root 3. So if I'm trying to find the remaining sides, I'm going to call them x and y. Let's go ahead and try and find x first. So I'm going to say x over root 3 equals, I'd have to use 11 over 1. So this is easy. This is going to just be 11 root 3. And then to find y, we're going to use the other sides. So we'll say y over 2 equals 11 over 1. So then cross multiply, y is going to equal 22. This is 22, and this is 11 root 3. Okay, last one, letter D. I'm going to redraw the triangle here. This is 60, this is 90, so that makes this 30. So again, across from the right angle, that's going to be a 1. The hypotenuse is a 2. The third side is a root 3. And if I'm trying to find the other leg and the hypotenuse, to find out x, I'm just going to set a proportion using 5, 1, x, and root 3. So 5 over 1 equals x over root 3. Cross multiplying, I'm going to get x to equal 5 root 3. Okay. And then last but not least, to find out what y is, I'm going to use y and 2, and then I'll also use 5 and 1 again. So I'm going to have y over 2 equals 5 over 1, cross multiplying, y is going to equal 10. Okay, so again, this only works for these special right triangles. Not all right triangles are like this where their ratios are always going to be the same. It's just in particular with 30, 60, 90s and 45, 45, 90 triangles. So let's try one more problem where we're applying how we're going to find the sides to find the area and the perimeter. So in order to find the perimeter, we obviously need to find all 3 sides of the triangle. So I look at my triangle and I see, oh, I have a 90-degree angle and a 60-degree angle. So that makes us a 30, 60, 90 triangle. So I'm going to redraw a triangle going in kind of the same direction. We're drawing the 60 and the 30 in the same places as my original. And across from the 30-degree angle, that's going to be the 1. Then the hypotenuse will be 2, and then the last side is root 3. So in order to find all 3 sides, I need to find AB, and I also need to find AC. So let's go ahead and do that. So let's find x first. So x over root 3 equals 7 over 1. Cross multiplying, I'm going to get x equals 7 root 3. And then in order to find y, I'm going to use y over 2 equals, I'm going to use 7 over 1 again. So y is going to equal 14. Whoops, I wrote 17. Just kidding. So y equals 14. And there are your 3 sides. So we can go ahead and find the perimeter now. So if x is 7 root 3 and y is 14, I'm going to add all these sides up. 7 plus 14 plus 7 root 3. Remember, I can't combine the root with the regular old numbers. So I'm going to have 21 plus 7 root 3 inches as my final answer for the perimeter. And then area is going to be the base times the height. And once again, remember the base and the height are where I have a right angle. So I'm going to take 7 times 7 root 3 over 2. And this is going to equal 49 root 3 over 2. You could also divide the 49 by 2 since it will be somewhat nice. You can say 24.5 root 3. This is going to be inches squared. Okay, so either one, whatever makes you happy. So that's level 1. Go take a practice trying your triangles, and you'll be good to go.